Hi, my name is Dino Girardo, and my capstone project is on autonomous contract analysis system, which is basically a research assistant for contract analysis and automated database management. So the problem that we have is our organization manages hundreds of contracts spanning 15 to 25 years, basically managing gas turbines. Our contract analysts manually have to go through these contracts and pull key data out of these documents and populate a table in an Oracle database so we can get basically the highlights of the contracts. So the process is slow and error prone and it's inconsistent. And some of the key pain points are ambiguous clauses, the manual extractions because of the number of pages each contract can have. Some can have over 100 to 200 pages. And we have several contract analysts, so the consistency of how some of these terms are interpreted can be different. And there are high stakes, basically, meaning, if we get something wrong in the contract, it could affect our overall backlog negatively. So why an agent-based approach? As you can see here, the prompt-only LLM wouldn't work because not being able to update the database, no memory across the documents, and a hallucination factor. And why an autonomous agent would work is because it would be able to update the database. We would be able to keep our documents in a vector store without having to expose all that data to the LLM. Like I said, it can write back to the database as well as we can ground the responses in the contract with the data in the vector store and also route any uncertain results to an analyst. So the system architecture of the system that I built had 4 agents. The ingestion agent, which basically takes the PDFs, chunks the data, embeds the contract into the Oracle vector store. The retrieval agent, which implements a hybrid search, a semantic and as well as a keyword search to pull the data out of the vector database. The reasoning agent, which implements a tree of thought with beam search, and I'm using Claude as the LLM, and the execution agent, which updates our database and also updates staging tables for analysis for our analysts to review the items that are uncertain. Some of the key decisions that I had to make during the while working on the project. The first one was a tree of thought. Here I created 3 candidate interpretations per field. And then I had the critic LLM using the Anthropic LLM. And we also implemented a deterministic post-reasoning override for date calculations. Basically, in some of the cases where, for example, we need to calculate the contract end date, the contract stipulated several stages of how that date would be calculated, and I'll get to that in a later slide. Another key decision was the hybrid RAG with neighbor chunks. So basically, in the beginning, I started with just a basic semantic search in the vector database, and we weren't getting the right output that we were expecting. So then we added the keyword on top of the semantic search, and then that got us a little better results. And in the end, we included the neighbor chunks just to get the full context of the question that we were asking, and that gave us better results. External data grounding, that was another key design decision. So basically, like I mentioned earlier, this is where we were pulling data out of our Oracle database in order to get solid dates for some of the things we needed to determine what our contract end date was. So if we were to pull a date, a valid date, we would give it a confidence boost for the tree of thought process. And the last thing was the tiered confidence thresholds. Basically, of all the 4 properties we were trying to pull, we had some general fields that weren't as impactful. And for those, we gave it, if it was over 75%, it automatically updated the database. And for high impact fields that had financial impacts, we required a 90% confidence rate in order to do an auto update. If it didn't do an auto update, then it would go to a staging table where an analyst would have to review the question. So an example of the tree of thought in action. So this one, the clause stated, shall expire on the earlier of date seller completed all services for final outage per Exhibit C or December 31st, 2041, which is the sunset date, which is basically the end of the contract. So it created 3 branches. The first branch is the date that we pulled out of the Oracle system. And branch B was the sunset date pulled out of the document. And branch C was something that couldn't be determined, so this branch was pruned. So branch A was the one with the higher confidence rate because of the extraction of the data out of the Oracle database, along with the fact that it is the lesser of the dates of May 1st, 2039, which was less than the date that was pulled out of the contract of 2041. So branch A was selected with a confidence of 92. So we ran a test against 10 contracts. And from those 10 contracts, we had 28 where fields were auto updated. So that means we had a 70% auto update rate. And out of those ones that were auto updated, they had a 91% average confidence for those items. The rest of the items were staged in a table for the analyst to review. So safety and reliability of the application, we did some input validation regarding the PDFs to make sure they were valid PDFs. If not, then we stop the pipeline right then and there. The retrieval verification, we validated the chunks. Basically, we took some of the values that were coming out of the chunks and compared to some of the values within the chunk to make sure they're the same. And another one was the output constraints, making sure the dates were in the right format, as well as the currencies were in a currency format as well. Tool access limits, we made sure that there weren't any drop or truncate commands when running the SQL statements. Escalation rules, like we talked about earlier, general fields needed 75% or higher to auto update, and the higher impact fields needed 90% or higher to auto update as well. And a circuit breaker, when you have 3 consecutive step failures, it would halt the pipeline. So implementation overview, these are some of the tools that we used in the application, and also the project structure of how the files were created inside the folders. As you can see, we use Python, like I said, Claude Sonnet, the autonomous database from Oracle, and also some of the Python tool sets to do the PDFs and date date procedures. So limitations and next steps. So we found that some of the limitations that we discovered was the embedding model that we used wasn't contract language specific. So we probably could have got a better result if we looked for a better embedding model. Chunk boundary splits. We had to do some things to get the chunks right. For example, the neighboring of the getting neighbors of the current chunks that we had just to get the complete picture. I learned that there's different uh, things you can do to get a better chunk. Regex date expression in order to get the right dates. I understand there's some tools that can do a better job as opposed to using regex to find dates. And also no change order support. So basically in contracts, you could get a change order that will basically update your contract or amendments that will update your contract. And right now we don't have that implemented in the solution. But realistic next steps is we also have contracts written in Arabic and Spanish that we'd like to test out. Domain embedding model, like we mentioned earlier, uh, trying to find a better embedding model that would give us better answers coming out of the vector database, and also expanding the field set to include more properties that we can store in the database, like guaranteed thresholds and escalation factors. And the last thing is basically being able to run this job in our Oracle environment. So closing reflection. So, before this class, I wasn't too familiar with what an agent can do. The only thing that was told of us was like, find a way to have AI improve our business. But my main takeaway from this is an agentic AI program incorporates concepts such as RAG, React, and Tree of Thought using LLMs that work together to produce a solution to a problem. So with that in mind, it just gave me the idea of this framework that you've taught us is able to solve an overall complex problem. Where before I just thought, you put something to a chat, get an answer back, and what can you do with that? But with this class, it really helped give me more ideas on what we can do to solve some of our processes in our organization. So basically, what I learned is the agent architecture, which is the separation of concerns across force of agents, the RAG pipeline, which was really beneficial when it comes to unstructured data, to put that into a vector database and ask questions against it. And also the human in loop concept, needing to get that validation from the real experts in order to get the public to trust the application. And what worked well for me was obviously the external data grounding resolved previously unresolved contract clauses, the relational database. We're already using Oracle, and that already came with the vector store, so we didn't have to do anything extra with that. And this was a pretty much first time I used Python, and I found it easy to use and very easy to debug. And also, this was the first time I did some software project using AI, using Claude, and it helped tremendously in producing the code as well as even producing this PowerPoint. So that is the end of the presentation. So I just want to thank you all for the class, and it really helped out a lot.